We use the exact same process to do these inequalities. We're going to talk about the polynomials and the rational inequalities. Remember that I'm wanting, when I solve an inequality or an equation, the set of points that give me a true statement when I plug them back into the equation. With inequalities, there's more than just one answer or two answers like what we've been getting. There's a whole region of answers. Remember that when I talk about an inequality, I am talking about greater than or less than. So if I had a polynomial and I had drawn it, and I knew the equation for this f of x, and I ask you, where's f of x greater than 0? Could you look at the graph and tell me where that was? It's the stuff that's above the x-axis, right? So it's the stuff from here, whatever that x value is, to that x value. And then it's everything from this x value on over, right? So the idea here is that we want to find, when we're given an inequality or whether it's rational or a polynomial, we need it to be less than or greater than 0. And if we will use that technique, then you can either look at a graph, or I will show you the boundary process where we look at these zeros, these places where it actually is equal to 0 as our boundaries, and we can look at those regions. So I'm going to teach you the region method. You can look at the equation. Again, we have a problem with the rational equations going in the calculator, right? It doesn't always show us all those points very clearly. So I like the boundary method best, and I'm going to show you how to do that for both of these. And the idea here, step number 1, is that you're going to set your equation so that it is either greater than or less than 0. So everything on one side, nothing left on the other side. I want everything on one side. Then you find the values of x so that f of x is equal to 0. So it is greater than or less than 0. And find values of x such that f of x equals 0. And then step 3 will be determine the regions where the inequality is true. Okay, so you got 3 steps to these. So you're going to set the equation so that, or solve the equation so that it's set equal to 0, or it won't be equal, it'll be less than or greater than 0. Then you're going to actually find where it is equal to 0. Those are your boundary points. And then you're going to determine which of the regions that breaks your number line up into that give you positive, or not as positive, but true equations. Like I said, the big thing that you got to remember is this piece right here. It's got to be so that f of x is either greater than 0 or f of x is less than 0. Can't have any x's or anything over there on that right-hand side. Just got to have 0 over there. You got it written down? All right. Check point 1. So we've got x squared minus x is greater than 20. Step number 1. We need to subtract the 20 from both sides. So I have x squared minus x minus 20 is greater than 0. Step number 2. Actually set it equal to 0, right, to find our boundaries. So I got x squared minus x minus 20 is actually equal to 0. That factors nicely into x minus 5x plus 4. Right? If it doesn't factor nicely, then you can put it in the quadratic formula, right? You always get an answer for these. So I've got x is 5 and x is equal to negative 4. Those are my boundaries. Now, you need to draw yourself a number line so that you can draw the graph that represents this solution. So you give yourself a number line. We're going to put our 2 solutions on there. If I get 2 solutions, do you see that I get 3 regions? I get the stuff that's less than negative 4, I get the stuff that's between the 2 solutions, and I get the stuff that's bigger. Okay? Now, this is always the part that I want you to make sure you do right now as you're drawing this. Go ahead and go back to those boundaries and look at your original equation. I wanted where this was greater than 0. So if this is equal to 0, can I have an open circle or do I need a closed circle? What does closed tell me? It includes it. And for it to include it, it would have to actually have a equal to bar. So I need to go ahead and put the open circles there to remind myself that I cannot include that number in my solution set. If you'll do it right there, it'll keep you from losing those points for that. Now, I'm just going to take any number that's less than negative 4 because any number I pick, it won't give me the same value back, but it will give me the same positive or negative sign back. So if there's anything down here that's negative, they're all negative. If there's anything down here that gives me a positive, they will all give me a positive. So I only need to check 1 to find out what kind of values I get. So I go back to my equation, or I go back to my sentence here, and I plug in negative 4, something less than negative 4, so negative 5. Or negative 7, I'm good with that. Plug in negative 7. If I'm finding f of negative 7, then what that means is I've got negative 7 squared minus negative 7 minus 20. Everybody see that? Now you be real careful when you plug in negative numbers and square them. If you do not put that in parentheses, your calculator is going to give you a negative 49, right? But we all know that that's not a negative 49. That's a positive 49. So 49 plus 7 minus 20 is a positive number. That's really all I care about. I really don't care what number value you get back. I just want to know, is it positive or is it negative? So since that's positive, everything in that region is positive. And I put a plus sign over the top of it to remind myself of that. And you really ought to take the time to physically write down what's your result that you get. Now I need something between negative 4 and negative 5 to check this region. 0's a nice one. Anytime I go from a negative to a positive, I use 0. Because 0's what happens with these terms. They just go away, right? So I get 0 squared minus 0 minus 20. So that gives me a negative number. So everything in there is going to give me a negative value. You can check a few other ones if you don't believe me. And then I need this last region, so we're going to do positive 7. Sounds good to me. So positive 7, I would get 7 squared minus 7 minus 20. Is that going to be a positive or a negative value? Okay. Everybody understand how I got that? Now what you do is you go back to this original equation. This is, I want the values that always give me numbers greater than 0. What kind of numbers are those? Positive. So my solution here is only the places where I got positive numbers. So what is my solution? So this stuff that's less than negative 4 and the stuff that's greater than 5. And how do I write that solution? And I got to use open parentheses, right? Unioned with 5 to the positive infinity, and again, got to use the open parentheses because I couldn't actually include negative 4 or positive 5. That's how you do all of these. Even when you have a rational expression. This is the best way to do it. Okay? Yeah. And in that case, then you use the square bracket because it includes that number. Okay? So let's look at checkpoint 3. Okay, this is the second objective when we did this with a rational function as opposed to a polynomial function. Now, same step 1. What do I have to have? Got to be the 0 over there, not that 1. So what do I need to do? Subtract 1 from both sides. So I've got 2x over x plus 1 minus 1 is greater than or equal to 0. Now, the difference with this is that for the rational inequalities to work nicely with this boundary idea, you need it to be just one fraction. So what I need to do is I need to make this use a common denominator. So I've got 2x over x plus 1 minus 1 times x plus 1 over x plus 1, right? Take whatever my denominator is, and I multiply the bottom and the top. I need 1. So I'm going to put it together now. For me to be able to have 1, I got to have the same denominator on them, right? When I add or subtract fractions or whole numbers, I was saying you got to fix this so that this will add together and become one fraction as a whole. 1 is 1 over 1. I just made it a fraction. 1 is the same thing as 1 over 1. Alright. So I get 2x minus x plus 1 over x plus 1, right? Take everything out of the first one, minus everything out of the second one, and over the denominator. Now, why did I write it like that, and what am I worried about you doing wrong? No, you cannot reduce unless it's multiplied. If these two are multiplied together, then I could reduce that out. I'm subtracting this off, so I've got to change the sign of both of them. So I've got 2x minus x minus 1 over x plus 1, which is going to become what? X minus 1 over x plus 1. That's 2x minus 1x is 1x minus 1. And I cannot reduce this, no, because they're not multiplied together and they don't have the same sign here. So what we do here is we set our boundaries again. Okay, we did all of that to get step number 1. Took all of those steps to get step number 1. I have to get it so that it's just one fraction greater than or equal to 0. Now step number 2 says I want to find my boundary. Okay, so I take the top and set it equal to 0. And I take the bottom and set it equal to 0. Okay? Everybody see what I did? Have to do them separately. Now, x is equal to 1. Am I going to be able to include this when I come over here and put it on my number line? Yes. Because it's the top, and the top can't actually be equal to 0, right? Because I got an equal to bar here. Now, this is the bottom. When I solve this one, can I ever have the bottom of a fraction be equal to 0? So anytime you do the denominator, when you put that one on there, you make sure you put an open circle around that, because you can never, ever, ever, it don't matter if it's equal to or not, you can't contain that point in your solution set. Okay? So again, I got 2 solutions. You know you can get 3 and 4 solutions, right, if you're doing a polynomial equation. All right, so now I just go back to my equation up here that x minus 1 over x plus 1, and I just put points in, test points, or test values from these 3 regions. So I need a number less than -1, -3. So I have -3 minus 1 over -3 plus 1, which gives me a -4 over -2. That's going to actually be a positive value, right? And then I pick a number between these 2. 0 is nice, right? Because it goes from negative to positive. I can always use 0 if my numbers go from negative to positive. So I've got 0 minus 1 over 0 plus 1, which is a negative number, right? -1. And then I check the stuff bigger than 1. That was +3. Gives me 2 over 4, which is positive, right? Then you go back to the inequality and you ask yourself, do I want the stuff that's positive or negative? Positive, because I want the stuff that's greater than 0. So my solution is from a -1 to a negative infinity, and from a +1 to a positive infinity. So when I write my solution set here, negative infinity to -1, and I can include -1, so make sure and put the parentheses, right? Union with the positive one that I can contain, so I'm going to use a square bracket on it, up to a positive infinity. There's my solution, and there's my graph. And then it does ask you to do both most of the time on these. They want the graph and they want the solution. Okay. Questions about that? That's all there is to it. There is one last objective in this section, and it's the application stuff. And I just want to point this out because on the word problems they're going to use this formula, and they're not going to give it to you because they gave it to you here. Every year in the homework set, the kids are like, I don't know how to do that. They forgot to come over here and get this formula, so I'm going to give it to you right now so you got it in your notes. The position of a falling object. So if something's falling, gravity's pulling on it, right? The position function is -16 t times the time squared plus the initial velocity times the time plus the initial height. And that is on page 400 if you want to look it up for yourself with all the words with the explanations. That's in feet. Now, if it was meters, it'd be something different, right? The position, the height of the object at any given moment. The sub-zero, that usually means initial. This is a physics equation. In most physics equations, when you have the sub-zero thing, it means the first one. So it was the initial velocity, because if it's dropping, it's going to speed up, right? So it wants its initial velocity and its initial height. Okay? Huh? S is height. S stands for the height in feet. Or even, like projected off of something. That's why the speed's in there. It's because, like you're just throwing a ball. Yes. No. taller it is up off the ground. Right. Well, it's just the height at any given moment, because it's S up to S with respect to T. So it's like whatever the distance, how high it is at any given interval of time. So after 2 minutes, you can find out how tall the thing is up off the ground. Okay? T is time, and S is the height. And all of those questions are answered in that box there, that blue box at the top of page 400, if you forget. Okay? It's all there on page 400. When you start doing the homework, it'll be there. Homework over this section is on page 401. You're going to do 3 through 60, multiples of 3, and then problem number 75.